That doesn't mean you don't have class. I'm going to get a sub. Okay, so linear equations and applications. So in the past couple things, we've been talking about expressions. So expressions don't have equal signs in them. Does that make sense as an idea? So it's just like a bunch of symbols and numbers and stuff, and you can simplify expressions, but it's not an equation. These are equations. Equations have equal signs. Something is equal to something else. And solving equations means figure out which value of x works in said equation, right? Does that make sense? Okay, so for this particular example, I think I would start by getting the x's on the same side. How do I do that? Subtract 4x.
Or 7x. You can do either.
Or 7x. Which one's easier? 4x. Is anybody going to super protest if I mean, I don't know. I get a little bit lazy sometimes. I don't write that step. So 3x minus 10 equals positive 5. I'm never sure at which stage I can stop writing steps. So if I don't do something, just let me know that it's confusing. Now what's next? Add 10. So if I don't write the plus 10, it's 3x equals 15. And then what's the last step? And x equals 5. And I'm not going to make you do this for every problem, but how would you know that you're right?
Plug it in.
Plug it in, yep. Like Glade, plug it in, plug it in. I'm sorry, bad joke. So does 7 times 5 minus 10 really equal 4 times 5 plus 5? So that's 35 minus 10. Does that equal 20 plus 5, yes or no? Yeah, okay, so you know it works. Has anybody ever solved equations where they get something that's like no solution or all numbers work?
Yeah.
Yeah, okay. And no solution can be kind of tricky at times. At times it's easy to tell, at times it's tricky. This one is one of the easier ones to tell. So I put this one on there because if students make mistakes, it's almost always with negatives, and it's almost always with distribution. So for example, I'm going to make a mistake on purpose. Make sure I have my eraser tool accessible. I don't know why this works that way. So if I say 4 minus 3t plus 6, yeah, that's okay. Do you see that that's where my mistake was? So what's wrong? It should have been minus 6. Okay. So there you go. Should be minus 6. Plus t equals 5t minus 5 minus 7t. Okay, so common mistake number 1 is not distributing the negative. Here's common mistake number 2, and I'll write it in red. Plus 3t plus 3t. Why is that wrong?
It's not the same.
Yeah, so I think about equations as equal. I have sisters who are twins, and you have to be fair with them. They're identical, and they think that life is fair, and they each get the same thing. Okay, like this is kind of weird. So this is like my sister Maggie, and I gave her 3t twice. My sister Katie got nothing. You see how like that is not going to work with your sisters, right? So this is it's kind of also people describe equations as being balanced, like whatever you add to that side of the equation, you add to that side of the equation, right? So you totally unbalance the equation. So I think I had a friend who said that when they were in high school, they called it the fairness principle, that whatever you do to one side or the other side, we'll call it the fair twin principle. Okay, so how do you proceed instead?
You add 3 to both sides.
How about this? I think that will work, but what about, I think it's better to combine like terms. Like treat this as an expression and combine like terms, and then treat that as an expression and combine like terms, and then go from there.
Yeah.
So for example, you could do 4 minus negative 6 is negative 2, and the reason is you can just flip the order of the negative 3t and the negative 6. Does that make sense? Mm-hmm. And you can flip order with negatives as long as the negative signs go with stuff. So that makes, if I combine this and this, that makes negative 2. And if I combine that and that, it makes negative 2t. And when I combine like terms on the right side, negative 2t minus 5. And now you're like, woohoo, business, I can add 2t to both sides. And you do that, and then something weird happens. Does 2t cancel on the left?
Yes.
Does it cancel on the right? Yes. And you get -2 equals -5. And yeah, you're like, that's totally crazy talk, right? -2 doesn't equal -5. So that is false, which means that there was never a solution to begin with. That's kind of something called a contradiction. You assume there is a solution and craziness happens. So that kind of no solution is easy to spot. What would happen, I'm not sure, some books define this as all real numbers, some books say, any x works. If you get a situation where any x would work, the statement that you get at this end, the x's go away and it's true. Like -5 equals -5 is true, and it's always true, okay? So that's one no solution. This next one, I'll tell you right now that it's also no solution, but I spent like 5 minutes trying to figure out why because I didn't see it right away. So let's solve it and determine why it's no solution at the end. It's not quite as obvious. So here, with fractions, the best thing to do is to get a common denominator across the entire problem. So what will your common denominator be? 6w, spectacular. So the left side already has 6w. What do you multiply the 1 over 2w by to make it into 6w? 3, so 3 over 3. And then 2w over 2w. So that gives me 3 plus w over 6w equals, if I say 3 plus 8w over 6w, does that make sense?
Yes.
Because I had a common denominator, so I could add the numerators, right? Tony doesn't like it. It's okay. Which part are you uncomfortable with?
I'm multiplying the whole thing by 6w and then I canceled.
That's totally fine. I'm going to do that next.
Okay.
Yep. So my next step is what Tani just said, to take this whole thing, both sides, and multiply it all by 6w. And that's the reason that getting common denominators on both sides is so awesome, because now what happens to the denominators when that distributes? They all go bye-bye. So 3 plus w equals 3 plus 8w. I mean, you don't like fractions anyway, just make them disappear. Which you can do with equations, but not with expressions. Okay, when you have equal signs, you can do things to both sides, but no equal sign, there's not two sides. Okay, now what next? Subtract 3, okay. So I'm going to get then w equals 8w. Now don't divide by w because technically w could be 0 and dividing by 0 is not okay. Dividing by 0 is just tricky when there's a variable, so be careful about that. How about minusing w? Does that make sense? If I take away w from both sides, I'll get 0 equals 7w. And then you can divide by 7. And w equals, so what is 0 divided by 7? 0. Oh, 8 minus 1.
Because you subtracted the w.
Because you took away the w. So at this step, I had w equals 8w, so I had a walrus equaled 8 walruses.
Oh, okay.
I took away 1 walrus, and now I have 7 walruses.
Okay.
Okay, and so I boxed this answer, and then I was working this problem out, and it was in the textbook, and it said no solution, and I was like, what the heck? I must be right, and the book must be wrong, and this is a good lesson, because guess what, the book wasn't wrong, and I was wrong. So,
Why will you divide by 0?
yeah, so look at the original problem. Do you see that w equals 0 is an issue? Because it makes a denominator 0. So this actually is no solution. Because w cannot equal 0. That's division. That's a tricky one, definitely. So just watch out for those. And actually what I would suggest doing, what I think helps me the most and help my high school students the most, is when you start the problem, write down what the variable can't be. Does that make sense? So like I would say, okay, this problem, w can't equal 0, because that makes the denominator 0, and then I know if I get that as my only answer, that it's no solution, and it'll leave it out. Does anybody else have a problem with like dyslexia and kind of knowing where the 0 can and cannot be with fraction? maybe you're all awesomer than I am, but here's my helpful hint. I had a student tell me this. Isn't that, I think it's helpful, right? Because like division by 0, which one is division by 0, right? So the 0 cannot be in the denominator. That's the no. The O is the 0, right? And the N is another number. But it's okay if it's in the top. So for example, 6 divided by 0 versus 0 divided by 6, which one's okay? The right one, and that one is equal to 0. It's like, how many 6s are in 0? None. The one on the left says how many zeros are in 6. Well, you could add 0 to itself forever and ever and never get to 6, right? That one's undefined. One thing you'll talk about a lot in Calc 1 is division by 0 using a thing called a limit. And the reason it's undefined is it isn't always equal to one thing. Like 0 divided by 0 is occasionally 1, it's occasionally 10, sometimes it's infinity. It just isn't, there are different sizes of zeros. Some zeros are smaller than others. That's weird, okay? But that's like calculus preview. Okay, so using the thing that I said about writing down what variable your, what number your variable can't be, which number would make this denominator 0? 1. So let's just write down that t cannot equal 1. So like I know if I get that as a solution to leave it out. And once again, common denominator, right? So we have t over t minus 1 equals 2 over t minus 1 plus 2 over 1. What do I multiply that last thing by? T minus 1, right? Over t minus 1. And at this stage, you multiply by the denominator, which make the denominators go adios, right? They're gone. So t equals 2 plus 2 times t minus 1. Does that make sense? Okay. And then distribute and go on your merry way.
Oh, you didn't show, but you did the canceling.
Yeah, I multiplied by t minus 1, and it distributes to every single person. Well, fractions. They're not persons, but, and then makes them all cancel. Yay! So t equals 2 plus 2t minus 2. So I think that's t equals 2t. Is that right? Agree, disagree? Yes? Gotta use your words. Sorry, that's like a thing you say to 5-year-olds. 0 equals t. I know you're not 5. Is that an okay answer in this particular case?
Yes.
Yeah, okay.
I hate it when the variable's t, because my t's look like pluses.
Here's how you can fix that. If you get in the problem, you can say let t equal x. And then you can use x throughout the problem. As long as you tell me that you've changed the variable, it's totally fine. The only and it doesn't matter because most of your homework is on Alex, right? So the only tricky thing with Alex, I'm pretty sure like other stuff, you have to give it the variable that it uses. Does that make sense? I had students with my WebAssign homework in my calculus class that the program used the variable t and they gave their answers in x's and everything else was right except for they used the wrong letter. Okay, so just have to be careful about that. The computer just doesn't know. So you need to be consistent if you can.
Or I want to divide by the number left over. So like
You want to divide by t, that's the, right?
by 2. So like t equals 2t, then I'd want to divide by 2.
Okay, so if you divide by 2, you get 1/2 t equals t. That's fine too. And then if you take away 1/2 t, you get 0 equals 1/2 t, right?
Or so I subtract it.
Yeah, that's the thing is you really don't want to divide by variables. That's the only thing that you got to kind of avoid.
Okay.
So like at this step right there, the one I'm circling right now, you want to not divide by t. Does that make sense? That's the most common thing. 'Cause if you do it, you get 1 equals 2, and you think it's no solution, right? Or what you could think about is think about equations in their simplest terms, like what number works in that equation? Like what number is equal to 2 times itself, and that number is 0, right? But the trickiest thing is if you want to get t's on the same side, subtract them. That's what I would say. Okay, this next one looks like it's gonna be terrible, and you're gonna need quite a bit of space for it, so you want to write a little small. It amazingly like works out beautifully. You can also make your T's curly, right? That's the thing. If you make your T's curly and your pluses straight, it'd be a little bit neater. Yes?
For some reason it says here to the bottom of the
Scroll down real quick. Okay, so does the x squared minus 5x plus 25 factor?
Yes.
I don't think so. It would have to be x squared minus 10x plus 25 to factor. Does that make sense? Or something else, but I think that would be that would be one way. So I was also convinced that there was a typo, but I was wrong again. So holy moly, which means that if you want to get a common denominator, what do you have to multiply the first fraction by? That whole big thing, and what else? X plus 5. Okay, so I'm so sorry, but we're just going to do it. So you got 1 over x minus 5 times big, old, unfactorable, evil polynomial. Because polynomials are like personalities. This one is the master. Does anybody besides me actually watch Doctor Who?
Oh, I watched Lost Doctor.
Oh yeah,
Okay.
you're not alone in this classroom.
Okay. If you don't, you should. -10. It's gonna be Missy for Halloween. Evil Mary Poppins. Okay, so what is the second fraction? Notice I moved the negative with the 10. I think that'll make stuff less confusing. What else does it need? What does the second fraction need to be multiplied by?
X minus 5.
X minus 5 and x plus 5. And man, I should color code those so it's more obvious. I'm so sorry. X minus 5, x plus 5.
How come you only did x plus 5, not x minus 5?
For the first one?
Yeah.
Because the first one already had x minus 5 in its denominator.
Oh, I see. Never mind. Sorry.
Yeah, that's what I said. I should have color coded it. Okay, so this is the thing we multiplied by. Does that help a little bit?
Yeah.
Okay. All right, and then equals, and I'm going to almost run out of space here. So equals 1 over x plus 5. And holy moly, what's that one going to need? It'll need x minus 5, right? And then what else? Big, huge, long thing, right? Now, don't cry and give up because you guys are tough pre-calculus students. Okay, my high schoolers can cry and give up because they're high schoolers, but you are not high schoolers and you need to, you know, even though maybe you technically are, but you need to behave like tough college students. Huh. Which means you do problems, even if they're, like, problematic. Is it clear that the denominators are going to go away so I can just, like, forget about them from now on? Can I skip writing down multiplying by it just because it's going to take up too much space and I won't fit it? Okay, so the denominators are gone. Now, multiply together these first two things, okay? So just take a second. You try, I'll try. I am going to just, yeah, so just, you might get stuff in different order, but let's just do it. So did you get possibly in a different order x cubed plus 5x squared minus 5x squared minus 25x plus 25x and plus 125?
Yes.
Okay, so you're, depending on how you distribute, you might get different order, but that's okay. A bunch of stuff will cancel, right? Does that make sense? Okay, the next ones, I am not going to do the minus 10 yet. So we'll have minus 10 times x squared plus 5x minus 5x minus 25. Oh my gosh. Ready for the right side? It's okay if you say no. I'm not. Okay, how about the right side? What are you gonna have? Ready, set, speak.
Same as that one.
I don't think it's the exact same.
Oh, it's not, no.
It's not, no, so it's x cubed, just distribute the x first, so x cubed. What comes next?
Plus 25x.
So, sure, wait. I think we need to work on our systematic behaviors. So first, it is best if you first distribute the x to everybody. Minus 25x squared. Otherwise, you're gonna not do everything. And then next, the x goes to 25, right? So plus 25x. And then what do you distribute next? The negative 5, yep. So negative,
So the minus 25x is just 5x, isn't it?
yes. See, that would have been a problem right there. That should have been 5x squared. Thank you. So x cubed minus 5x squared, yep, plus 25x, and then minus another 5x squared, plus 25x, minus 125. Holy moly, okay. It will get better now that some stuff's gonna cancel. Like a whole bunch of stuff cancels on the left, doesn't it? Yeah. So from the first thing that I underlined in red, what cancels?
Everything except x cubed and plus 125.
Yep, so we're gonna have x cubed plus 125. Okay, x cubed plus 125. And then inside those parentheses in blue, what cancels there?
5x.
5x's. So we're going to have minus 10x squared. And is it plus or minus that comes next?
Minus.
Mm-mm. It's plus 250.
Oh, yeah.
Equals, how about on the right side when you combine like terms? You get x cubed. Do those 5x squareds cancel? You got negative 5 minus 5 more. What does that make?
Minus 10.
Minus 10. And then I think that's 25x plus 25x. Is that right?
Yes.
So plus how many x's then? 50. And then minus 125. Whew. Yes,
Can't you cancel things?
from each
For the
side?
For the left side, I canceled a lot of them off.
Oh, you totally can. Yeah, I'm going to do that next. Like you can cancel the x cubes, right?
Yeah.
And you can also cancel the x squareds, I believe.
Yeah, so like
Yep.
I have a different expression.
That's okay. You might, as long as you get the same answer, you might have a different expression in the middle. So I think what we've got, we take away x cubed, and then what happens to the x cubes?
Poof.
Poof, they're gone. We add 10x squared. Hello, grab a sheet. And then they're gone. Okay. So just not to do too much at once. Does that make sense that this is now 375 equals 50x minus 125? And then you add 125, and I think that's 500.
Yes.
And x equals 10, right? Yeah, you can totally do stuff at different rates and different orders. You didn't get 10?
No, I got 5.
I know 10 is right, because I got it in it twice now. Oh,
Should probably cancel off the 125.
yeah, that probably is what happened. You probably thought the 125 is canceled as opposed to combined to 250. Does that make sense? You see how at this step, one side is minus 125 and one side is plus, they don't cancel?
Yeah.
Yep. Okay, all right, so there's the big, long, nasty problem. Now, sometimes you're asked to solve equations for variables. So has anybody ever seen
bottom's canceled. is
Yes.
what I thought. So I did it where I tried to show it, but when I did that, I got like -10 over x to the 5th.
I have to look at your work to see what's
so
up,
I'll show you
okay?
after.
Show me after, yeah, because it's just gonna not help everybody else. So show me after. Formula F equals 9/5 C plus, yeah, what's up, Tom? Okay, so has anybody ever seen this formula? What do you think F and C stand for?
Fahrenheit and Celsius.
Fahrenheit and Celsius. So as it is, like, so for example, at my house, I have a thermometer, and the only thermometer that we could find that goes down to -40 was a thermometer for a freezer, and it's only in Celsius. It came from China, it was like $1. But, so I have to always convert Celsius into Fahrenheit when I'm gonna go run and figure out what kind of clothes I have to wear.
Or you could just figure out Celsius.
Shush, 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 shush. So, but in my head, I figure out Celsius by converting from Celsius to Fahrenheit. And the way you do that is you take 9/5 times your Celsius and you add 32. Now, what if you're European and you want to go the other way? Okay, what if so you've got to solve this for C. And so get the C by itself. And so how would you start to do that? Minus the 32. Yep, so F minus 32 equals 9/5 C.
Multiply my sides by,
Yep. Can I do it a little bit different way? Can I do 5 first and then divide by 9? Does that make sense? So multiplying by 5 first, that will make 5F minus, okay, what's 5 times 32 without a calculator? So 5 times 30 is 150, plus 10 will make 160. Good. Equals 9C. And so then you divide by 9, and you're going to get 5 over 9F minus 160 over 9 equals C. And usually you put the thing of equal on the left, you say C equals 5/9 F. You could also, there are lots of ways to write that correctly. You could also say 5F minus 160 and the whole thing over 9. That's the same thing. Does that make sense? Some books might write this as 5/9 times F minus 32 and not distribute. Also the same thing, okay? So as long as your answer is correct and equivalent, you're going to get full credit, right? Okay. So if you guys are looking at being an engineer, apparently this has to do with some kind of electrical circuits. I'm not an engineer. I don't know how, but apparently it has to do with
It does.
resistors or something, probably.
It's a simple parallel circuit.
Okay, so sometime after class explain parallel circuits to me, okay, but not right now. So we want to solve for R1. Okay. So I'd like to do this problem in the way that makes the most sense to you. So if you looked at this, what would be your first thing you'd like to do?
1 over R minus 1 over R2.
Okay, does that make sense? Take away the 1 over R2? Okay, so 1 over R minus 1 over R2. Okay, great. All right, now what? The R1's in the bottom. You can't just say it's equal to R minus R2, can you? Common denominator, yep, does that make sense? So get a common denominator on the left. So multiply this first one by R2 over R2, the second one by R over R. So that's going to be R2 minus R over R2 equals 1 over R1.
Forget the D2s.
Say that again.
You forgot the D2s.
What D2s?
Star Wars.
Oh, R2D2. Oh man, the Doctor Who jokes and that. Okay. All right, now at this step, has anybody ever heard of cross multiplying? Yes, it's pretty useful, yeah. So technically what you do is you multiply by R1, and what does that do to the thing? What does multiplying by R1 do to the R1 that's in the denominator on the right side? It goes to 1, so you get R1 times R2 minus R over stuff.
So why is it RR2 and not R3?
Because it's
Oh,
They're-
subscripts are names, not powers.
They're like different variables, essentially.
So it's kind of like saying X, Y, Z. Does that make sense? Yeah, it's a great question. It's kind of like in the slope formula, you have y2 minus y1 over x2 minus x1, and those twos refer to like the first point and second point, but they don't refer to anything else.
Okay.
There's a way of labeling like first, second.
Okay.
Is the math that I did to get that next step okay? Okay, now how would you get the other denominator out?
Multiply.
Multiply by it. So R1 times R2 minus R is equal to R sub 2. And whoo, you're almost done. Why am I so excited? Because you're almost done. What do you have to do to be done? Divide by,
R2 minus R.
you want to divide by R2 minus R. And the reason is you want to get R1 all by itself. If you divide by R1, it's going to end up back in a denominator. So your final answer is R1 equals R2 over R2 minus R. That is not the only way to do that problem. There are other ways. Okay, that's just, so if you think you've got something else that's the same, just ask. All right. Ready for example 5? So solve something for y, right? Okay. This one's a bit different because there's two y's, right? Okay. So, my first instinct is to get that y minus 3 out of the denominator. Does that make sense? Multiply by it. So we have x equals 2y plus 2 over y minus 3 multiply by y minus 3. And that gives me x times y minus 3 equals 2y, oops, crud, I wrote it wrong. That should be 3y plus 2. My bad. 3's don't magically change to 2's. I should know better.
Not if you divide by 0.
Okay. Is everyone okay with that first step?
Yes.
Yes, okay. Now distribute your x, so you get xy minus 3x equals 3y plus 2. Get all y on same side. That is the trick. To get this solved for y, the thing you have to do is get all of the y's on the same side. Everybody that has no y goes on the other side. Okay, so this, how are you going to move this 3y over there? Subtract it. And then what thing from the left side has to go to the right side? 3x. So that gives me xy minus 3y equals what?
3x plus 2.
3x plus 2. And here is the tricky bit. Now both things on the left side contain a y, right? What you do is you factor it out. It's the greatest common factor. And that takes those two y's and makes them one y. So y x minus 3. See that?
Then you just
Divide by x minus 3. So 3x plus 2 over x minus 3. Don't cancel those x's because you'd be killing some kittens. Students often try to find a different way to do that problem, and I have never come across someone who's found a different way that's been right. Okay, so if your different way works, show me because I'm interested. But that is in general, the easiest way. And you'll have to use that in calculus, that whole technique quite a bit. So if you ever have, like, say, two variables and they're both, like, to the first power, the technique is to get them on the same side and factor them out. So that's almost always the way. And my guess is that that gave students a lot of trouble in, like, Algebra 2 class. Yeah.
So, in this case, what type of equation wouldn't work for just swapping x and y? It's the same exact equation except the variables are swapped.
Oh, I see what you're saying. Yeah, there definitely is a pattern.
I get it, you found it and I used that, but
There's a pattern for how you get from this. Whoa, what?
yeah.
Oh, whoa. That does. Okay, this is one of those instances where I pick something and a coincidence happened. That does not always happen. Holy. What?
Yeah.
What? Okay.
I got the negative equivalent because
So your numerator is negative. Yeah.
But if I just
Multiply by -1 on top and bottom, you get the same thing. Yeah. Okay, that does not always happen. That is a coincidence, okay? Do you guys see what he saw that I didn't see?
Oh yeah.
I mean, no, doesn't always happen. There is a pattern, like as into how the numbers sort of switch. And if you want to be challenged, what you can do is take the equation x equals, let's say, ay plus b over c y plus d, and you can see what happens. Like as in solve that for y and look at how the letters move, okay? But the fact that that switched, that nothing changed, that is totally a coincidence and is not always like that. Okay, that it's not actually that easy. I need to adjust my problems, but I can't believe I didn't even see that. And it's because I did the problem wrong. Oh, awesome. I made my two, never mind. We're just moving on. Okay. Okay, so explain why these statements don't make any sense. So solve P equals 2L plus 2W. Why does that make no sense? They didn't tell you what for. Yeah, so you need to be told what to solve for. As in, they would have had it in, solve this for L or solve this for W, right? Otherwise, the problem makes no sense. Why does the next one make no sense? Solve this thing.
Solve an expression.
Yeah, you can't solve an expression. So you can't solve an expression. And this is something that sometimes even teachers like don't say right. The correct directions, they would say simplify. And you take solve as meaning, oh, solve is the word that applies to all math problems, right? But solving specifically does refer to equations. Does that make sense? So versus simplifying an expression. So just be careful with your vocabulary. I'll correct you if you're wrong, and I'm not gonna like be mean to you, but just FYI. Okay, now on to the story. So a celebrity couple wants to have a rectangular pool put in the backyard of their vacation home. Somebody has too much money. They want it to be 24 meters long so that they can swim laps. And they insist that it have at least as much area as the neighbor's pool, which is 12 meters on a side, because you have to keep up with those other like rich neighbors. So here's their pool. It's rectangular. One side is 24. The other side is yet to be determined by their pool architect, which is you. That's your job. And they want it to have the same like area as the neighbor's pool. So if the neighbor's pool is 12 meters on a side, that means that their pool is square, right? And it's 12 by 12. So what is the area of that neighbor's pool?
It says on a side, not each side.
Wash. What? Look at it, says each now.
Okay.
So that's 144.
So the neighbor's pool is 144, yep. So you're gonna have the area of their pool has to equal 144. So what is the area of their pool?
If you want to be really picky.
Just shush, okay? What is the area of their pool? 24x equals 144. And so then to get x by itself, you divide by 24, right? So I think you get x equals 6. So 6, let's say, meters.
So we're making it equal to 144 because it needs to be at least that
size.
Yeah, so that's the smallest one. Does that make sense? So they want it to be at least, they want that to be then they say find the dimensions of the smallest pool. On Monday, we'll solve inequalities where you actually will use like the alligator symbols.
I was gonna say, since it's a rectangular, it's not implied that it has to be, equal side lengths. So technically, it could be smaller,
That technically it could be,
because it's a rectangle and square.
Yeah, isn't this a inequality?
Yeah, it is equal.
they were careful about their words.
Smallest.
Smallest pool that meets that criteria. So technically it is x is bigger than or equal to 6. As in like if they had said that, if they said like, find any, like the lowest, but all they wanted with this problem, because they wanted to solve an equation, not an inequality, is the one that would just meet it exactly. That's the smallest possible one. Does that make sense? But in section 1.1-2, we'll be talking about inequalities. So you guys are just, I don't want to say you're overthinking it, you're just thinking about it in, sort of like the extra right way.
So
Yeah.
I have a question, like, there's a typo there, obviously, for the A side, we changed it to each, is that just,
Yeah.
was that a book typo or just a typo?
I'm not sure because I'd have to look at the book to see, because I assume they're gonna give you enough information to solve it, and I'm not sure if they said A or each.
Yeah, cause if it was A, I don't
If
think
it was
that would
A,
be-
you just have to ask, but I just assumed that it meant that it had to be square because they didn't give me any more information.
Yeah.
Does that make sense? So I'm not sure if the A in that
Well,
case means,
It works out kind of nicely because 24 and 12 work together. So you could say that the other side is.
but you
X
shouldn't
divided
assume the
by
problem
2.
is the way it is because it works out nicely. But I think that in this case, if all they give you is that much information, I think it's safe to assume it probably means it's square. But it is true that you might want to, like if this was the real world and this really was true, everyone ask for clarification, like is there plural square? So, okay, let's do another one, because the next ones, each of these are a little bit different. So, I used to work at a sporting goods store and they mark stuff up 50%. This place marks it up 60%. So you have the wholesale price, which is the price that places buy stuff at, and then you have the price that you pay, which is more, right? So what is the wholesale price on a snowboard that sells for $144? So I did this two ways. Here's the way that I think will make the most sense for you. So how much they charge you is both how much they pay, so call that W. Does that make sense? And then how much more do they charge you? So 0.6 times W. And that's gonna equal how much?
1.6.
Okay, it does equal 1.6 W, yes. Equals 144. Do you see that this 1.6 is also 160%? So that you could also have thought about it that way. It's 100% plus the 60% more. Does that? And so then W will equal whatever 144 divided by 1.6 is. And on a quiz, I'll either make it like work out super nice so it's no calculator, or I'll let you use a calculator. But for the first quiz, is no calculator. Yeah.
I was gonna do it, 144 times 0.6 and then subtract whatever that was from 144, would that work or no?
Let's try it, because I didn't do it that way. So this way is 90. Okay, so you told me that you were gonna do, say it again?
144
Uh-huh,
times 0.6
times 0.6.
times whatever that equals, or subtract 144 by whatever that equals.
Okay, so, sorry, I can't process, say it one more time.
Alright, so 144
Uh-huh,
times 0.6
uh-huh,
and then equals. And then whatever that equals,
mm-hmm.
subtract from 144.
I don't think it works.
That works.
Yeah, it's because you're finding 60% of that number. And that's going to be more than 60% of the wholesale price. Does that make sense? Yeah. So there might be a different way to engineer it, so you could use subtraction, and I just haven't thought enough about it to think about that way. But I know this way works. And it's a little bit different if you have like a discount sales price kind of thing going on. So let me think about that one more, like not in front of 23 people, and see if I can engineer it to make it so you can use subtraction somehow. Does my way make sense, though?
Yeah.
Okay, great. Awesome. All right, and the next one's about jobs. So you know that some jobs you get paid commission, right? Where you get paid a certain percentage of how much stuff you sell. And often you get paid a base salary as well, just to make you, in case you don't sell anything because nobody comes. So suppose you work at a computer store and your base salary is just over $1,000 per month, and you get a 5% commission on all the sales during that month. How much do you have to sell to earn a total of $3,170? Okay, so you want your pay to equal $3,170. You're trying to figure out, like, okay, is this even possible for me to sell this much stuff, right? So does it make sense that you just get paid the 1,175 no matter what? And how about X equal the amount sold in dollars? So 1,175 plus how much times X? 0.05. Otherwise, you're going to get paid a 50% commission, in which case it's an awesome deal. 3,170. And once you get the setup, it's super easy to solve. You take away the 1,175, and that gives me 0.05x equals 1995. Probably about when you guys were born. And then what do you divide by 0.005? What do you get? 39,900. So, wow. Well, if the computers are about $1,000 each, that's about,
That's a little over one computer per day.
yeah. So maybe it's possible, right? You have to decide how good you are at selling stuff and how much you can handle being pushy when customers tell you to go away, right? Okay. Yeah. Commission's kind of, yeah, it's interesting. It's a weird way. I sold bikes at a bike store, and look, I tried to. I knew that there was a problem like this in the textbook that I used to teach out of, and I went and found it just for you guys. This is a true story, and it's about Alaska. No one's else excited about it. Okay, so St. Paul, Alaska, St. Paul Island in Alaska. You guys know where that is, approximately? It's out in the Bering Sea, between here and Russia. So this is like, wait, how do you make the Alaska map? Like this, right? That's the Alaska map. I think that St. Paul Island is like out here. Like, no.
Islands.
There's St. Paul and St. George, I think. So this is an island in Alaska, and there are fur seals. There are fur seal rookeries there, so where these fur seals breed. And they wanted to estimate the population of fur seals in 1961. A very common technique is they go out there and they put tags on some of the babies, and they let them go. And then they collect another sample later and they use it to estimate. This is called the catch and release technique. They also use it with fish. So they tagged 4,963 fur seals, and they let them go. And then later in the month, they observed this many pups, and they found that many were tagged. This is going to be a proportion. And so what I mean by that, we have tagged over total. It's only approximately equal, and there's lots of ways to do this correctly. So in their first sample, how many seals were tagged?
4,960.
So 4,963. And I'm going to put that over, do you know the total population?
No.
No, so I'm going to call that like capital N. So N equals total pop. And that's going to be about equal to what over what? 218 over 900. And if you use exact equal signs, that's okay, but you understand this is not going to be an exact sign, it's not going to be perfect, right? But it's going to give you a pretty reasonable estimate. This is used in all sorts of stuff. I'm positive it's used for fish tagging. I know it's used for this. And now, once you have a proportion, you can cross multiply. Does that make sense? So you multiply n and 218 gives you 218n is about equal to huge number, and the huge number is 4466700. and then, you divide by 218, and you get N is approximately equal to 20,489.4. So you can say N is about 20,500. Does that make sense? It's not exact anyway, so you might as well just kind of round. I'd say at least round to the nearest whole number, right? But isn't that kind of cool that you can use something really, really simple to estimate population size? Because you can't possibly count all the seals, right? They're going to move around and they're going to be tricky, right? That's how you can estimate how many there are. It's also a lot less work than counting every single one, isn't it? Yeah. Okay. Awesome. Now, this is also a really practical problem, and I must say that I think these mixture problems are quite tricky. So you have this much fuel, and it has a 0.9% sulfur content. And this exceeds the pollution control standards that say you can only have a 0.8% sulfur content. So you have other fuel that has a lower sulfur content, and you've got to figure out how much you add to the stuff you have to bring the sulfur content down. And I'm sure this mixing stuff happens in all sorts of things, probably making jet fuel pure enough and all that kinds of stuff, not just this class. Your book has a great picture. So it has the 0.3% stuff. You don't know how much you have, that you're going to call that X. Does that make sense? So X is the amount. Plus the 0.9% stuff, how much of that do you have? 120,000, yep. And so your total amount is X plus 120,000. Does that make sense? Like the total amount of gallons that you have. Okay, so that's the first step. And what is the goal percentage for that last one? 0.8, yep. So that isn't our equation yet, because what haven't we incorporated? We haven't incorporated the percents yet, have we? Does that make sense? So how do you find 0.3% of X? Almost, times by 0.0003, right? So you take 0.003x, because 0.03 would be 3%, right? Yep, okay. Plus 0.009 times 120,000. That will equal how much sulfur content can be in your end amount. 0.008, exactly. 0.008 times the quantity, X plus 120,000. And the trickiest thing is getting the equation. Once you got the equation, it's not so bad, right? It's just lots of decimals. So 0.003x plus, that ends up being 1,080 equals 0.008x plus 960 is what I got. And from that point in time, what do you do? Subtract. I think I'm going to do that. I'm going to do the other way, but what you do is work. I'm going to take away 960. Just keep stuff positive. And what else could you do in the same step? Exactly. Great. Okay, so 1080 minus 960 is 120 equals 0.005, and X is equal to 24,000 gallons. Okay. I have 2 minutes. I think I can do the last one. So how about you read the problem real quickly? So you have 2 pumps, and one pump can put gasoline into your storage tank in 8 hours. And when you use a second pump, it takes just 3. So the question is how long would it take the second pump to fill the tank if it was operating alone? And these problems are a bit tricky. I think they're a little bit tricky. But what you do is you make these things into rates. So for pump number 1, which is your crappy pump, pump number 1 does 1/8 of a tank per hour. Does that make sense as an idea? If it fills the whole tank in 8 hours, it does 1/8 every hour, assuming that it goes at the same rate and doesn't die on you. Do you know how much the other pump does?
I know it's faster than 1/8.
You know it's faster than 1/8, but you don't know specifically how much faster, right? So here's pump number 2. Pump number 2 does 1/x of the tank per hour. You just don't know what proportion.
And so how come it's not 3 hours, or 1/3?
Because the 3 hours is how much they do together.
Oh, simultaneously.
Simultaneously, yep. But you're right, if it would have said the pump number 2 can do it in 3 hours, then it would be 1/3. And the problem would be a little bit different. Yep. Okay. Now, does it make sense that pump number 1's contribution plus pump number 2 equals 1 tank in 3 hours? Does that idea make sense? Like pump 1 does something, pump 2 does something? If you go for 3 hours, how much does pump number 1 do? How many eighths?
For 3 hours?
For 3 hours, yep. So it'd be 3/8. Does that make sense why it's 3/8? It's 1/8 3 times. The other one does 1/x 3 times. So 3/x. And so together they do equals 1 whole tank. I know it's fractions, but can you probably solve that? Like get a common denominator? So multiply the first one by what? X/x. Second one by 8/8. And the other side by 8x/8x. And the denominators cancel. You get 3x plus 24 equals 8x. Take away the 3x. 24 equals 5x. And 24/5 equals x. Just to get a clue, you know that it should be faster than the other tank. That's also 4.8. Okay, so that's the end of today's lesson.